Hey y'all, today is Wednesday, September 29th, and we are working on our notes for lesson 2-5. Now, before we get started with our notes, I want to look at this image right here. So this right here is called the coordinate plane, and there's some vocab that I want to go over real fast in regards to the coordinate plane. So first of all, there are two axes on the coordinate plane, two major lines. This first one that runs horizontally or from side to side is called the x-axis. And it runs from side to side, from left to right. The other major line that I want to talk about is this one that goes up and down. That one that goes up and down is called the y-axis. And a lot of times these lines will just be labeled with either x or y. That's it. They won't always have x-axis written out or y-axis, just x or y. Okay, so those are two major lines that you need to be able to recognize. Now where they meet in the center right here, that right there is called the origin. And the points for the origin are 0, 0. The points for the origin are 0, 0. So the very center of the coordinate plane is called the origin, and the coordinates for it are 0, 0. Now, I do want to talk about how I wrote that right there. Okay, so coordinate points or coordinates are always written in the form of x, comma, y. And you do put parentheses around coordinates. So it always starts with the x coordinate first, and the y coordinate always comes after that. Okay? Now, keeping that in mind, let's figure out what this point right here would be. So this would be 1, 2, 3, 4. And on the y-axis, we go up 1, 2, 3. So that would be the point 4, 3. Notice I labeled my x coordinate first and my y coordinate second. Okay? So that would be the point 4, 3. Now there's one more thing that I want to talk about in regards to the coordinate plane before we move on with our lesson. I want to talk about quadrants. You can see that there are 4 quadrants or 4 sections of the coordinate plane. So every graph that we look at today will be just this quadrant right here. And that quadrant is called quadrant 1. Sometimes you see it labeled as Q1, like that, quadrant 1. And then you count your quadrants counterclockwise. So this one right here is quadrant 2. The one right below that is quadrant 3. And then this last one right below quadrant 1 is quadrant 4. Okay? But every graph that we look at today, like I said earlier, will be in this first quadrant. So now that we've gone over that information, let's get started with our lesson. So Tanya exercised for 30 minutes. She noted the calories burned at 3 times during her workout. How can Tanya use this information to find out how many calories she burned after 15 minutes of exercise? Okay, so the way I figure out which quantity goes on the x-axis and which quantity goes on the y-axis is I ask myself, what depends on something else? So when I'm reading this problem situation, I recognize that her calories that she burns depends on how much time she spends exercising. The more time she spends exercising, the more calories she burns. So I know then that the amount of calories, so the number of calories burned depends on how much time she spends exercising. So the number of calories burned depends on the time. Okay, now the thing that depends on something else, that's our y-axis. So that means that calories burned will be on our y-axis on our graph. And on our x-axis, we're going to put time. Now, I'm going to go ahead and tell you right now, that is really hard to decipher sometimes, and you do not have to do that. You will not be doing that on a quiz. You will not be doing that on a test. So don't worry. I will help you learn that as the year goes on. Okay, but now that we've talked about that, let's move on. We need to first find out if this is a proportional relationship. So we have these almost like watch face looking things. They kind of remind me of my Apple Watch. And so in the first one, I see that she burned 95 calories in 10 minutes. So I'm just going to write a ratio. And I'm going to start with calories over time. So 95 divided by 10, whether I put that in a calculator or if I do it in my head, I know that that's going to be 9.5. Okay, let's move on to the next watch face. She burned 190 calories, so I'm going to put that on top because I'm keeping it consistent, in 20 minutes time. And when I put that into my calculator, 190 divided by 20, again, I get 9.5. Let's move on to that third watch face. We've got to write our ratio, but we're going to keep it consistent. So calories on top, 285 calories in 30 minutes time. And when I put that into my calculator, when I divide, I do in fact get 9.5. So every single time here, I got the same thing. So that tells me that I have equivalent ratios. So the question is this a proportional relationship? How do you know? Well, yes, it is. And I know this because of equivalent ratios. So now let's move on. I've already got my graph for this problem situation right below this. So my graph is right here. So what do I notice about the graph? Well, I notice it's a straight line. It's going up. And I notice that it starts right here at 0, 0. It starts at the origin. So we've already determined that this is a proportional relationship. So this tells us some key information about proportional relationship graphs. We know that the graph of a proportional relationship will be a straight line that goes through the origin. It goes through the point 0, 0. Well, why does it make sense that it goes through the point 0, 0? Let's talk about what this point 0, 0 represents in this problem situation. Okay, so 0, 0. Remember, my x value is that first 0 and my y value is that second 0, right? So what this means that in 0 minutes time, or if she spends 0 minutes exercising, so in 0 minutes, she burns 0 calories. And all that really means is that if she doesn't exercise, she doesn't burn any calories. So it makes sense that our proportional relationship graph starts right there at the origin. Okay? So every single graph of a proportional relationship will be a straight line that goes through the point 0, 0. Now let's look at the next little section. Use the graph to find K, the constant of proportionality. Okay, well to do that, we're going to pick any point on the graph except for 0, 0. So pick any point and divide y by x. Pick any point and divide y by x. So I like to pick my smallest point, the first one that I see labeled. So I'm going to use this one right here. So it's labeled for us 1095, right? So that's the one that I'm going to pick. And remember, it is written as x, y. So to show my work over here, we know that K is Y divided by X. So in this case, K is 95 divided by 10. And 95 divided by 10, when I put that into my calculator, I know that that's going to give me 9.5. So K is 9.5. Okay, now use K, the constant of proportionality, to write an equation for the graph. Well, our form is y equals K times X. So we're just going to plug in 9.5 for K right there. That's all we have to do. So y equals 9.5 times X. And that is my equation for this graph. And in part B, we can also use that constant proportionality to identify other points. So the question asked earlier at the very beginning was, how many calories did Tanya burn in 15 minutes of exercise? Okay, well, 15 minutes. Minutes, remember, was on the x-axis. So I'm going to plug in 15 for my x value into my equation that we wrote right above. Okay, so we have y equals 9.5 times x. So y equals 9.5 times 15. And I'm going to put that into my calculator. And 9.5 times 15, when I put that into my calculator, I get y equals 142.5. And we know that these are calories burned. So 142.5 calories. And we can also verify that answer using our graph. So when I look at how this is labeled, I know that that first gray line is 10 on the x-axis. So 2, 4, 6, 8, 10, 12, 14, 16. So 15 is right above that, or right in between 14 and 16, right? So I'm looking at minute 15. So it's going to be about right there, right? Okay. Well, when I look at my y-axis, how things are labeled, I see that that first gray line is 100. So 20, 40, 60, 80, 100. So then we have 120. We have 140 right here. And we see how this spot is just right barely above 140. So 142.5, I feel really, really good about the answer that we got right there. Okay, moving on to try it. Each 1/4 cup serving of cereal has 3 grams of protein. How can you use the graph below to determine whether the quantities are proportional and to find how many grams of protein are in 1 cup of cereal? Okay, so when I think about this problem situation, I know that the more cereal I eat, I'm going to consume more protein. So the amount of protein depends on the cereal consumed. So the protein depends on the cereal, right? Because the more cereal you eat, the more protein you get. So the thing that depends on something else is your y value. So the protein would be labeled on our y-axis on our graph, that vertical axis that goes up and down. And that means that the amount of cereal would be on our x-axis that goes from side to side or horizontally. So we're first going to figure out from a table if this represents a proportional relationship. So I've made a table over here, and it tells us that each 1/4 cup serving of cereal has 3 grams of protein. So there's 1/4 cup. I know that there's 3 grams of protein. Now 2/4 cup, remember, is the same as 1/2 a cup of cereal. I just reduced that fraction. 2/4 is the same thing as 1/2. So in 1/2 a cup of cereal, there's 3 more grams of protein. So there are now 6 grams of protein. And then 3/4 a cup of cereal, there's another 3 grams of protein. So I now know that there are 9 grams of protein. So I want to find out if this right here is proportional. So the way I'm going to do that is I'm going to take my y value and divide by my x value. So let's look at this first row. So we've got 3/1. I'm going to write that 3 as a fraction. And I'm dividing it by 1/4. Now, whether you put this in your calculator or you do it by hand, you know how to divide with fractions. Keep, change, flip. So we have 3/1 times 4/1. I flipped that second fraction. And then I just have 3 times 4, which is 12. Okay, so let's keep on going. Let's do the same thing in our second row. So I'm going to write 6 as 6/1. So 6/1 divided by, and you could use either 2/4 or 1/2. I'm going to use 1/2. 1/2. So 6/1 divided by 1/2. Well, keep, change, flip. Keep 6/1, change division to multiplication, and flip so you have 2/1. Well, 6 times 2 is 12. So far this is proportional. Let's look at our last one. I'm going to write my y value as a fraction. So we've got 9/1 divided by 3/4. Well, keep, change, flip. We keep 9/1. We change division to multiplication, and we flip so that we have 4/3. Well, here I do see that things reduce. My 9 and 3 will reduce. 3 goes into both of those. 3 goes into 3 one time, and 3 goes into 9 3 times. So now I just have 3 times 4, which again is 12. So every single time I got 12. Well, what does that mean? That means that this is a proportional relationship because of equivalent ratios. So, is this a proportional relationship? Yes. How do I know? We have equivalent ratios. Okay. Now let's look at our graph, and we actually have to make the graph this time. This is the only time so far for this year that you will be making graphs. You won't be doing this on your test or on a quiz. So we're going to use the values in our table. So we've got 1/4 on the x-axis and 3 on the y-axis. So 1/4 on the x-axis is right here, and 3 on the y-axis is right here. So I'm just going to see where they meet. So right there and right there, they meet at that point. So that's the point that I'm going to plot. Okay. Our next value in our table is 1/2 and 6. So I'm going to see where those two meet. So 1/2 is here, and it goes all the way up to there, and then 6 goes all the way to there. So right there, that's going to be the point that I plot. Okay, and then the next point I plot is going to be 3/4 and 9. So 3/4 and 9 is going to be right there. And we can see very clearly that we do have a straight line. If I connect all of these points, I definitely get a straight line. But right now it doesn't go through the origin, correct? But we know this is a proportional relationship. So let's think about, can I also plot this point right here at 0, 0? Would it make sense for me to extend my graph down to 0, 0? Well, what that would mean is that if I eat 0 cups of cereal, that I consume 0 grams of protein. So yes, that does make sense. If you don't eat any cereal, you're not consuming any protein. So we can, in fact, extend our graph all the way down here to 0, 0. So this is a proportional relationship. We have a graph that is a straight line, and it goes through the point 0, 0, which is called the origin. Okay? We also know that this graph would keep on going, right? And we'll talk about that in a minute. So the next thing says to use the graph to find K, the constant of proportionality. Remember, the way we do that is we pick any point and we divide, y by x. We pick any point and we divide y by x. It doesn't matter which point we pick. So again, I like to pick the smallest points. So that very first point was 1/4 and 3. So remember, this is our x value and this is our y value. So I'm dividing 3 by 1/4. So k equals y divided by x. So k equals 3 divided by 1/4. Well, I'm going to rewrite that. So we have 3 over 1 divided by 1/4. Well, keep, change, flip. So we keep 3 over 1, change division to multiplication, and then flip that second fraction, so it's going to become 4 over 1. And 3 times 4 is 12, 1 times 1 is 1. So that right there tells me that k is 12. So now use the constant of proportionality to write an equation for the graph. So we're just going to plug in our value for k right there. Everything else is going to stay the same. So y equals 12 times x. So now the question is, how many grams of protein are in 1 cup of cereal? Remember, the cups of cereal were labeled on the x-axis. So all I have to do is take my equation and plug in 1 for x. So our equation was y equals 12 times x. So y equals 12 times 1. And 12 times 1 is simply 12. So y equals 12 grams of protein. So that right there is our answer, 12 grams of protein. Okay, let's move on to the next page. We'll look at example 2. So the graph shows a proportional relationship between the distance and the amount of time Mr. Brown drives. So in A, what do each of these points represent in this situation? Okay, so we're going to figure out what these points represent. And the way I like to do this is I like to start with my y. And then bring in the x after the y. So remember, points are labeled as the x value first and the y value second. Okay? And this is all about Mr. Brown's road trip. So the y value here is that he drives 0 miles. So he drives 0 miles. And the x value tells us how much time. So he drives 0 miles in 0 hours. In other words, if he doesn't even drive, if he spends no time driving, he covers 0 miles in distance. Okay, let's look at the next one. Remember, it's written as x first, y second. Okay, so keeping that in mind, I like to start with my y. So he drives 55 miles. So he drives 55 miles, and then the x value tells us how much time in 1 hour. He drives 55 miles in 1 hour. And then the last point, we have 5 to 75. So remember, it's written as x comma y, and we're going to start with our y. So he drives 275 miles in, And the x value tells us our time, 5 hours. He drives 275 miles in 5 hours. Okay, part B, what is the constant of proportionality? Okay, so to remember this, or to find this, we're going to use this formula, K equals Y divided by X. So we pick any point on the graph and take our Y value and divide it by X. So I'm going to pick this first point here, because that first point is 155. The only point that we cannot use to find the constant of proportionality is 0, 0. So I'm going to use this one here. Remember, we write it as X first, Y second. So I'm going to say 55 divided by 1. So K equals 55 divided by 1, and 55 divided by 1 is simply 55. So K is 55. That is our constant of proportionality. So what equation relates the distance Y and the time X? So we're going to write an equation using K, Y, and X. And our formula for our equation is Y equals K times X. So all we have to do, since we've already found K, is plug it in right there. That's the only thing that we need to do here. So our equation is Y equals 55 times X. And in part D, suppose the graph was extended. Find the ordered pair with an X coordinate of 7. What does the point represent in this situation? Okay, so first of all, the ordered pair means we're going to find the point on the graph. And points are written as X, comma, Y, right? So we're finding a point, and it tells us with an X coordinate of 7. So we're finding this point right here, 7, and then we don't know what our Y is. So all I really need to do is I need to plug in 7 for X, and I'm going to plug it into the equation that we already wrote. So we wrote the equation Y equals 55 times X. So I'm going to plug in 7 right there. So Y equals 55 times 7. Okay, so you can do this in your calculator, but you really don't need to. It's pretty simple. 55 times 7. 7 times 5 is 35. 7 times 5 again is 35. Plus 3 is 38. So 385. So Y equals 385 what? 385 miles. So to answer this question, that's not the answer. I'm not going to box that in. We wanted to find the ordered pair. So the ordered pair, or the point, would be 7, 385. Okay, if we extended our graph and it had 7 hours on it, we would have this point 7, 385. Now, we're also asked, what does this point represent? Well, let's start with our Y. He drives 385 miles in 7 hours. And that's what that point represents. Okay, moving on to example 3. Determine whether each graph is proportional or not. Explain why. So looking at our first graph, I see very clearly that it is a straight line. That right there is a straight line. I also see very clearly that it starts right here at the point 0, 0. And remember, proportional graphs are always straight lines that go through 0, 0 or the origin. So, is this one proportional? Yes. So this one is proportional because it is a straight line and it goes through the origin, which is the point 0, 0. Okay, let's look at our next graph. Okay, this one here, I see that it is a straight line. But in order for it to be proportional, it has to go through the point 0, 0. Okay, and this one we see very clearly, it does not go through the point 0, 0. So this one right here is not proportional. And the reason this one is not proportional is because it does not go through the origin, which is the point 0, 0. Remember, it has to go through that point. Okay, moving on to the last one right here. So first of all, this graph is not really a straight line. It kind of does that weird curve thing, right? So it's not a straight line. It does go through the origin. It goes through the point 0, 0, but it is not a straight line. So because it's not a straight line, this one here is not proportional either. So if that one were a straight line, it would be proportional, but because it's not, it is not proportional. That right there is the end of our notes. Tomorrow we will review lesson 2.4 and lesson 2.5.